Well, okay, let me begin by saying it depends on what you mean by saving. If you want to preserve social stability of humans, very adverse climate change could threaten that, especially in fragile societies with fragile agricultures. And can science do this? Yes, but it needs more than just science because it has to be boosted by policy to nudge it forward. At the beginning of any new technology, it's always going to be more expensive, and so you need that. Some of the technologies are getting better, cheaper, so you don't need it as much, but there are others, I mentioned a few, that really need a little kick. And so I think you need both the science, but also the policy commitment and the recognition that you better do it because it's going to take a very long time. And now's the time to start in earnest.
So Steve has spoken eloquently about the challenge with respect to energy and an allied challenge, agriculture. I would like to echo a remark that Professor Haroche made in his lecture earlier in the day. It is also important that science can make a key contribution to human health, especially that of an aging population, which will be a growing problem in the world, with dire consequences for the world economy, and then downstream from that, of course, difficulty in solving other pressing problems.
Yeah, I think there is no question that we need to save or to protect the Earth, but I think the basic issue is education. Even before science, we have to have a population which is aware of the problems, which can think in a rational way, to which we can explain what's happening without raising irrational fears. And this is one of the big issues. So I think education, starting with young children, all over the education cycle is very important to make citizens in all countries understand that there is a problem and there's a rational way to solve the problem.
I like the breadth of answers and the different domains in which the problem needs to be stated and then the answers are to be made. I was having a conversation this morning with a member of the audience who's His Excellency Daniel Noboa, the President of Ecuador. And we were talking about all of the species that were extinct on the Galapagos Islands because of, whether it's human intervention or climate change or other reasons. And the point was that science is the only answer to trying to stop the extinction of creatures or to do something about it. So governments are becoming a lot more receptive to not just allow scientists in, but use scientists as key advisors or leaders within the government itself. Professor Chu, you were actually in the seat of a government official. What can we do as governments to ensure that science is not just allowed, but let's say accelerated in terms of government use of science and the ability of scientists to do more within the different governments of the world?
Well, I think the first thing is the scientists have to be at the adult table. In the United States, the adult table are members of the cabinet. If you're one or two levels below that and it has to percolate up, it's not the same. And so when scientists have direct access to the head of state, it means it's so much different. And so I was the first scientist cabinet member in the history of the United States. I hope, and that's a little stunning, you think, but if you look around the world, it's average, as many people don't have any in that position. So it's very important that you get them at the head table.
And Steve, there's only one PhD scientist amongst the 453 members of the United States House of Representatives.
So we need more representation of scientists within government. I think that this is something that resonates with many people, not just in the room, but around the world. Because the approach that scientists take is they identify the problem and they're able to really go back to first principles, whether they're physicists or people that are in similar situations to yours, to understand the root cause and then solve it. And I think we need that kind of thinking within government. Professor Kornberg, biggest challenge that we have today is the concentration of scientists in certain geographies. So it's mostly in the West, or let's say the United States, or the East, and let's say China. For other nations that have the ambition to become science-driven economies and science-driven nations, how can they compete with the large players, or at least complement them, to attract scientists and to do more, to be players in this domain?
So one is often asked, why should a smaller nation attempt to compete? And why shouldn't they simply rely on what is published, the results of science that are done at great expense in the larger and more wealthy countries of the world, and apply science? And I think the fundamental answer is in relation to their human resource. If they don't offer opportunities to the best and the brightest in their countries to pursue knowledge in the way that my colleagues here and we as the scientists, the participants in the World Laureate Summit have all done, then they will migrate to other countries. And you will lose what is the most precious of all natural resources. At the same time, it enables every country to make best use of whatever is discovered elsewhere. It is truly practicing scientists who are capable, I think, of offering good advice for how to exploit what is found elsewhere.
The UAE was historically a crossroads for commerce, for goods, for logistics. And I think with the move of the World Laureate Association's headquarters to the UAE, it will become a crossroads for the best brains of the world. And this is maybe our small step towards creating this flow of scientists through different geographies. Yeah. Professor Haroche, on this stage in 2016, there was a discussion on how artificial intelligence is going to change the world and how governments need to react to this tsunami that is approaching. And the UAE government did not just react, it was proactive in appointing a minister for AI and doing a lot in that. Today, there are similar calls for quantum computing. And people are saying that quantum is the future AI and it's the most important technology. What do you say to that?
Okay, first I would like to make a comment about what has just been said. You compared United States with China, and I think in the middle you have Europe, and I am the only European here, and I can tell you that middle-sized countries have a very good way to do science, which is to unite, to have common programs to the different countries. The ERC, for example, the European Research Council, was very helpful for that, and I think this could be an example for countries in the Middle East to have common effort, a common program in science, and for countries in the extreme East, Japan, Korea, Singapore, Hong Kong. I see that they don't work enough together, and they could take example on Europe to do that. Now, about quantum technologies, this is still a field which is building up and at the border between basic science and technology, and it is still largely basic science. Everybody is talking about the quantum computer. This is a kind of dream. In the future, it does not exist. And if you think about the next 10 or 15 years, the quantum computer will not contribute at all. On the other hand, you have other quantum technologies which are more mature. For example, now you have probes which are able to measure extremely small changes in the gravitational field of the Earth. And this is a kind of probe which could be used to monitor the level of water or the level of ice, which is an important part of the research about climate change, to monitor and to keep data and to update the data all the time. Another aspect of the quantum technologies is called quantum simulation. What you can do is to build up one by one artificial system which mimic what happens in real matter. And in this way, you can try to synthesize material which do not exist yet, but which could be useful. Everybody is talking about superconductivity at room temperature. If we had this kind of device, of course, it would solve part of the energy problem because the transportation of energy has a lot of losses due to losses in cables. You could also think of quantum technologies to synthesize new molecules which could be useful for health, human or animal health. So there is a lot of domains in which you can see that one day this quantum technology will be helpful. I can give you another example, which is not directly linked to global warming, but you could think that the ultra-precise clocks that were now being built would be able to detect the beginning of an earthquake, because if the Earth moves, clocks sense that they change very slightly their rate due to general relativity effects, and this could be used one day to build stations which would monitor earthquakes and monitor motion of the Earth's crust. You have also very precise, very sensitive probes of magnetic and electric field, which could also be used for studies of the Earth's atmosphere. So there is a lot of fields. What I am always cautious about is not to promise things in advance. By definition, research is something which is looking for unknown, and only you can predict the technological advances over a very short span of time, 2, 3, 4 years. But beyond that, you may have surprises, good surprises. Steve alluded to fusion, which, of course, if you had the energy coming from fusion, it will solve a lot of problems. But there are still a huge technical problems that Steve alluded to. And this is also something which is quantum. After all, to understand how fusion works, you need quantum physics. So it's and also the research on nuclear and fission power plants, it also requires a lot of research, especially if you want to build small power plants and have a more scattered network, which would require artificial intelligence to be able to manage it. So all fields of science and physics collaborate together to solve these problems.
I think Professor Chu, he threw me off. I was going to ask you another question, but if you'll allow me to ask you 2 questions, which you can answer rapidly. The first is, what's your prediction on fusion? When do you think we're going to be able to achieve stable commercial fusion that can, change and revolutionize energy around the world? Just if you can give us like a quick prediction on that. But the second, which is more important, the US is at the forefront of artificial intelligence. And there was an experiment that was done in a research paper that was published on whether or not AI can actually achieve discovery of science. So not just help you in the process, but do the scientific discovery itself. And the answer was no, that at this point it can't, maybe it can in the future. Do you think it will ever be possible?
The first question, 30 years is the minimum, never as a maximum, but maybe optimistically 30 to 50 or 60 years, a commercial. As I spoke about, the materials problems are enormous, and we haven't just begun to try to even address that. In terms of AI, I think as human beings, we have to be a little more humble than we have been, but I think that's also impossible. We always try to define ourselves as being different from anything else, as being smarter than any machine, starting with the Turner test and on through. And so now the last bastion is, well, can there be as creative as an Einstein? And say, from a simple idea that of equivalence principle, you can develop general relativity. Who knows? But I wouldn't underestimate it, because I see historically over hundreds of years, we redefine intelligence so that a machine doesn't catch up with us. But it's, I would say, learn to use it as best we can and work with it.
I see a different opinion, I guess.
I have been asked this question too, and I think that AI is not creative in the sense of humans. To be creative, you need to be driven by passions like curiosity, ambition to give a contribution to the world knowledge. You need all these things are in your brain, are chemical reaction in your brain. Emotions are not just circuits. And so I don't think that a machine like even a sophisticated AI machine could have this kind of creativity. Maybe it's wishful thinking, because I will be
Let's
very
hope
upset.
not, or those will be famous last words.
Excuse me?
If I could just add, in the areas that I know where important discoveries were made, they were contrary to all existing knowledge. And AI, which only has the knowledge base available today to go on, could not possibly have drawn a conclusion completely contrary to every other source of information available.
But let me just add, it's these accidental discoveries that really drove progress. But once they have the accidental discoveries, humans have been just, now we can understand even more deeply. And then the question is, can machines ever be able to do that? The creativity part is slightly different. And that's why I use Einstein as an example of, just out of nowhere, you can create something. Machines are very far away from that.
Yeah,
But Einstein, for example, succeeded by making assumptions contrary to what everyone else believed was possible, speed of light, what have you.
and I think you also need to have a sense of beauty, of symmetries. Nature is full of symmetries, and you have to appreciate these symmetries. This is what physics is doing. And I think all the great scientists in the past had this feeling about beauty. They were also interested in music, in art, in literature. And you have to combine all this to have really genius and creative.
And that's how molecular biologists came up with a genetic code which was wrong by seeking the most parsimonious solution, and it was incorrect.
This is giving me an idea. I think for the next year, we need to have the great debate where we have the three of you and we bring three of the people who are shaping the future of AI, and we actually debate this out, because this is an exciting conversation which the hunch is that you're absolutely correct. But the way that this is progressing in ways that we didn't anticipate a few years back. So even up until 2020, not a single person could have predicted a large language model to be able to do what it was able to do in 2022. They thought that was 15 years in the future. So that should be an interesting topic. I'd like to conclude maybe with a question relating to the thing that you guys have been busy with the past couple of days. So we've convened some of the leading scientists of the world. We've had 2 very productive days. What are the most important outcomes that you think came out of the World Laureate Summit? What can people expect to be the impact that will change their lives from the discussions that you've had? Whether it's new knowledge, new insights, or at least something that government officials can take forward to implement after your discussions.
Your Excellency, if I may, having sat through that entire period and listened, what struck me was how many of the presenters spoke as requested about their own science, but then took trouble to call attention independently to what is the most important message we as scientists wish to deliver to the policymakers of the World Government Summit. The importance of what we call basic science, which is untargeted research, which is the source of all discovery. It's difficult to explain both what is basic science and why it matters. People need to understand that it is paradoxical, that if you want to solve the most difficult problems that we face, you cannot accomplish it by tackling them directly, but only by pursuing a curiosity about nature. And then, unexpectedly, in the nature of discoveries, and by their very nature, solutions will emerge. The other important point for government, the timeline, as my colleagues here will attest, is often very long, 20, 30 or more years. You take the example of general relativity, which proved to be applicable, as Serge has just said, to important problems only probably after 70 years. The important point is only government will support this crucial human activity with such a long timeline. You cannot imagine a CEO of a company telling his board that he wants to support research that's going to take 20 or 30 years and may or may not yield any valuable result. Only governments will support basic research.
Well said. I think that's a great concluding remark that hopefully will inspire the officials in this room and those who are watching us online to at least take certain action to support science in their governments and in their domains through the next year. And hopefully we'll be able to meet again at the next World Laureate Summit and the next World Government Summit to discuss the outcomes and the future of science. Thank you all very much.
Can I just add, maybe Serge, we're going to go a little bit over time. One of the things that these conferences do is they're personal interactions, and you're talking with people, and there's feedback. And right now, AI, for example, doesn't do that. It scarfs up stuff from the internet, and it's only a one-way street. It's through the interactions and the feedback that puts everything on a different basis. This is the why you have conferences. This is why you actually come here and meet people face to face. And it's that personal interaction you want to keep alive.
Your Excellency, that was your wisdom in making this possible. It was to enable a large group of scientists to speak directly to many leaders of government, of industry, and of finance. And we thank you for that.
And what I think is remarkable is that what Roger said about the importance of basic science was shared by all participants from all fields, physics, biology, medicine. We all have this feeling that, in fact, above even the fact that it might be useful for something one day, basic science is a part of civilization. There is an aspiration of kids, of human people, of all ages, to understand better the world. And by explaining basic science to children, you can start some careers. Some young people might be attracted to science because they are fascinated by basic issues. After that, they might go to technology, to applied science. But if you want to attract bright minds to science, you have to expose them to the basic question that basic science is addressing.
Absolutely. Thank you all once again. Thank you.